Hello all. Welcome to the second video lecture on Unit 1, Computer Networks and Security. In the previous session, we discussed about various networks based on its size, namely LAN, WAN and MAN. In today's session, we are going to discuss about the network topologies, which is nothing but the way of interconnecting network components. The various topologies are given on the slide. We have mesh topology, star, bus, tree topology, which is also known as extended star, and ring topology. Combination of any two or more topologies is known as a hybrid topology. Now we will see each topology in detail. Now, when we have a network topology, we need to test or measure the parameters based on the following criteria: whether there is a possibility of data congestion due to the interconnectivity pattern of the topology, whether the network is robust or not, whether it is maintaining the data privacy of the sender, then the amount of hardware required, fault identification and difficulty in fault correction. This means whether we can isolate the faults or identify the faults easily in the network topology, and once found, whether it is easy or difficult to correct the fault. And the last criteria is effect of failure of a link on the whole system. If one link fails, whether the whole system will crash or it will not affect the other parts of the network. So let us start with the mesh topology. As you can see in the diagram, in mesh topology, each station is connected to every other station through a dedicated link. In the last session, we discussed about point-to-point communication. So these links are point-to-point links running between various stations, and the communication between those stations will happen only over those links. Now, this is the speciality of mesh topology, but the features are the hardware required or the number of cables required are n into n minus 1 by 2 duplex links. In the example given, there are 5 stations. So the number of cables required, you can verify that. Number of cables required will be 5 into 4 upon 2, that is 10. So the amount of cables required are quite a lot in case of mesh topology, thereby increasing the cost of the whole network. The second point is no data congestion problem. This is obvious because we have dedicated links. No data between various senders will cross each other. Then one link failure does not affect the whole system. Again, the reason is same. We have dedicated links running between various stations or pair of stations. So even if one link fails, the other pairs can communicate with one another without any problem. Data privacy is also maintained. Same reason of dedicated links. And easy fault identification. If there is a problem in communication between two stations, obviously the problem lies either in those two stations' network interface card or the link which is running in between them. Then the next topology is a star topology. In the diagram, you can see we have a centralized controller which is called as hub, and to that hub there are various stations that are connected. Now let us see the features of the star topology. We have a presence of central controller. This central controller is also called as a switch. We will see what are the various types of switches and what is the difference between hub and switch in later part. This topology is less expensive than mesh. The reason is the number of cables that are required are exactly equal to n if you have n number of stations. Unlike mesh topology, where we do need n into n minus 1 by 2 number of cables, which increases the cost of the whole network. One link failure does not affect the whole system because again, the stations are independently connected to the hub. The only disadvantage is if the central controller only fails, then the whole system is going to crash. Fault identification is also easy because again, we have links running between stations and hubs. So the issues with communication from one station, we can isolate the other part of the network and check only the station, hub port and the link running between them. This is the disadvantage we already discussed. We have a dependency on the central controller. We have another topology which is called as tree topology, which is also known as extended star. As you can see in the diagram, we have various star topologies connected together through a hub or again a central controller. The boxes with yellow color are nothing but central controllers to which various stations are connected. And then those hubs or switches or central controllers are again connected to one more or higher level central controller. This makes it a tree topology or extended star topology. The features of this tree topology are exactly similar to star topology. Next one is bus topology. Bus is nothing but a single cable which has two different ends, as you can see in the diagram, and then through a drop line and a tap, the stations are connected to that one cable, which is also called as backbone sometimes. This is an example of multi-point communication where there is a shared media, shared channel to which various stations are connected. Now, looking at the diagram, we can very well guess what can be advantages, disadvantages, or in short, features of this bus topology. The data privacy will not be maintained because we have shared media. We will go through the features one by one. We have multi-point communication. Limited number of devices can be connected as signal weakens after a certain distance. We know that when the signal travels a certain distance, there is an attenuation. So there is a limitation on number of devices that you can connect to a bus. Ease of installation, you can add the devices easily using a drop line and a tap. No fault isolation, because if there is an issue between the communication between a station or two different stations, it is very difficult to find the fault in which part of the network the fault lies, because again we have a shared media. Privacy will not be maintained. Cost is moderate. Then next topology is ring topology. If you connect two ends of bus topology, that will make it a ring. So as you can see in the diagram, we have a ring. There is no open end to this cable. Again, the media is shared. So the disadvantages of bus topology also are there in the ring topology. Each device connected to two other devices. Signal transfer may be slower. Easy to install and reconfigure. Easy to add devices. Again, if you see the criteria, privacy may not be maintained. Cost is moderate. Fault isolation and fault identification is also very difficult, because in which part of the network there is an issue, it will not be very easy to find out, as again it is a shared media. Now let us proceed with the next topology, that is hybrid topology, which is combination of multiple topologies. We can see two diagrams. On the left side, we can have bus topology, ring topology, and star topology, which are again connected to a central controller, which makes it a star topology. But it is a combination of bus, ring, and star, so we will call it as hybrid topology. Similarly, on the right side on the slide, we have three buses which are connected to a central controller, which is making the whole system as a star topology. But individually, if you see, for each port of the hub, there is a bus. So this also is a hybrid topology. Now that comes, here we are at the end of this session. Let us just summarize what we discussed. We have various topologies. Mesh topology. All the stations are connected to each and every other station. Then we have a star topology. We have a central controller and stations are connected to it. Then we have tree, which is nothing but extended star. We have bus, where we have a shared media or channel, multi-point communication. Then if you connect two ends of the bus topology, that will make it a ring topology. If we can combine various topologies together, we have a hybrid topology. Then the criteria based on which these topologies are compared or can be selected are fault identification and isolation, data privacy, amount of hardware required, and then the cost associated with it, then effect of failure of one link to the whole network, and whether the network is robust or not. So these are the criteria based on which you can select a network. Now, many times when a network is to be designed, the designers have to decide which topology should be used. So the criteria that we discussed on the very first slide, second slide in this session, is the most important criteria based on which the topology will be selected. If a network can afford, or the designer can afford a cost of the network, then that designer or that network will have a mesh topology, because it has all other advantages. But usually the cost is too high, and that is why a middle way is found, and many a times in the LAN, star topologies are used. In many cases, it is extended star. This is not hard and fast rule. A network designer can decide which topology to use only based on the criteria that we already have discussed. The designer has to take the decision, and in many cases, due to many advantages, star topology is widely used and very popular topology. Now we will see a few questions which you need to think upon. What do you think about the data privacy in star topology? This point we have not discussed in this session. Please think over it or try to find out the information. Second is, find out which topology is used in PICT LAN. Anyway, we are going to discuss PICT LAN structure in later part of this course. However, on your website, you will be able to find the information about PICT LAN. So now we will stop this session. Thank you.